Okay guys, let's take a look at today's lesson. So we're starting off a new unit on sequences and series. This is actually pretty important in calculus. In Cal 2, we do sequences and series. So in Cal 1, if you're taking AB next year, you really won't encounter sequences and series in Cal 1. But in Cal 2, BC is Cal 1 and Cal 2, we do look at sequences and series in Cal 2. So let's take a look. So today is basically working on some vocabulary words and some basics about sequences and series. Many of these things you probably already remember or are new from last year. A sequence specifically is an ordered list of numbers, and each number is known as a term. That's just a vocab word, it's a term. So we have a sequence, it's just a list. There are couple of different kinds of sequences. We can have a finite sequence, which means that they stop. They're just a specific amount of numbers. Or we could have an infinite sequence, which means that they keep going, forever. An infinite sequence, there's a little bit more to one of those. It actually may approach a unique number or a limit. And if it does, the sequence is said to converge. So this is a big calculus word right here, converge. So if the sequence is headed to a particular number, then it is said to converge. If it doesn't, if it just keeps getting bigger and bigger and bigger, or smaller and smaller and smaller, then it's said to diverge. We probably did not talk about that last year. That might be new. The nth term is basically the formula that generates the sequence. So that's another vocab word. There's two different kinds of formulas that we deal with. One is called explicit formula, which means that if you let's say I want the 100th term. Your term numbers are n's, right? Say I want the 100th term. If I plug in 100 for n, I would get the 100th term. That's an explicit formula. It gives the nth term, which is a sub n, as a function of n. So it's a function of n. So it has the availability, very flexible type of formula where I can find any term number I want. Recursive formula, on the other hand, is a bit more structured, it's a little bit more rigid, and that is you have to, first of all, you have to give people terms to start with. You can't just give them a formula and say, oh, here you go, here's recursive formula. You have to start somewhere with one term or two or three, just depending on how the formula is created. And then the formula defines the terms using the previous terms. So for a recursive formula, if you wanted to do the 100th term on a recursive formula, that would take a little while. You would need the first 99 terms to be able to find the 100th term. Or you might just kind of give up and try to translate it into an explicit formula, because that would take a long time. Now you're thinking, or I'm thinking, what would we need a recursive formula for? And to be honest, really computers are quite quick with recursive formulas, right? It wouldn't take a computer very long to get to a 100th term given a recursive formula. So there are some usefulness or uses for recursive formulas. Partial sums. For partial sums, that's pretty much a big deal right here. It's a huge concept for us in calculus, a partial sum. And it's really kind of straightforward, though students really get it confused. Basically, the sum 1, partial sum 1, is just the first term. If I want partial sum 2, what that means is I take the first term and I add the second term to it. It's not the second term, it is the sum of the first and second terms. If I want the third partial sum, then I would take the first term plus the second term plus the third term. You see how that works? So if I wanted the fourth partial sum, then I would add the first four terms, and so on and so forth. That's how we get partial sums. Now, there are times when we need to find a formula for the partial sums, which we could think of as a sequence of partial sums. So if I got all the partial sums, or got several of them, I could many times generate a formula that would create them. And lastly, the last concept we're going to look at today is summation notation, or sigma notation. This is the Greek letter sigma. It is basically a command. It's telling you to do something. Just like the square root, when you see square root of 4, you know what you're supposed to do, right? You would square root the 4. And when you see, greatest integer value of 2.5, you know what it's asking you to do, right? It's a math symbol that gives you information on what you're supposed to be doing. As far as the sigma notation is concerned, it's telling you you're supposed to add some things up. That's what it's telling you. This symbol stands for sum. It's a sum. And what does it want you to add? It wants you to start at the first, this particular one wants you to start at the first term and go to however many terms it says, the nth term. And so we're just adding them all up till we get to the nth term. So we do have properties of sums. There are some things that we are allowed to do, just like if you recall, like limit properties. There are some things you're allowed to do with limits. Well, there are some things you're allowed to do with sums. If I am looking at the sum of two different functions, let's say, I am allowed to split them apart and do the sum of the first function and the sum of the second function and then add them together. That's an okay thing to do. Likewise, if I am doing the sum of a couple of functions that are being subtracted, I am allowed to do them separately. Sum up the first one, sum up the second one, and then subtract the results. That's an okay thing to do as well. The third property is, let's say I have a function and I'm multiplying it by 5. Well, I am allowed to pull that 5 on the outside, do all the sum of the function, and then multiply by 5. Those are all okay things to do. You are allowed to rewrite it that way. Okay? Questions so far on just the background vocab? All right, today's lesson is going to require a calculator. Hopefully you brought one with you. If you would get that out. We're going to use the calculator in a couple of different instances. Okay. So there's a few problems on here, and I'll take you through some calculator input. So the first example is asking us to find the nth term of the following sequences. So nth term just means the formula. Find the formula that generates it. I really think that these are a little bit more difficult than arithmetic and geometric sequences, because at least in arithmetic and geometric sequences you have a formula to start with, right? At least you know, well, this is the formula I'm going to use. With these types, you are just kind of, guessing and checking. It's really what you're doing. You're just trying to figure out what can I write to create this formula. So what I like to do when I'm faced with one like this that I have no idea really, it's not arithmetic, it's not geometric. First of all, if it's a fraction, I like to look at the numerator and denominator separately. I would like to think of something that would generate the numerator and something that would generate the denominator, instead of trying to find something that would generate 1/2 and 3/4. That's a little bit too overwhelming. I want to look at it piece by piece. The other thing that I would do is I would write the term numbers up here, because that kind of gives me some focus. I'm kind of focusing on, I need to write some kind of an equation where if I put a 1 in, I get a 1/2. And if I put a 2 in, I get a 3/4. That's what I need to be thinking. What can I use so that if I put a 3 in, I get 5/6? All right, it looks like the denominator is much easier to work with than the numerator. So let's start with the denominator. If I put a 1 in, I need a 2. If I put a 2 in, I need a 4. A 3 in, I need a 6. Do we see that pattern? If I put a 4 in, I need an 8. So my a sub n term, I think kind of clear, it should be 2 times n, right? If I just do 2 times n, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and so forth, I get the denominator. Now the numerator just so happens to be 1 less than the denominator. Right, do we see that? So the numerator is a 1, that's 1 less than 2, a 3, 1 less than 4. So I can really take the formula that I used in the denominator and just subtract 1. Okay, so that's one way to get the formula. There are other ways. You could have recognized that the numerator is an arithmetic sequence, right? 1, 3, 5, 7, and you can just use that formula to generate it. And you could recognize the denominator is the same thing. It's 2, 4, 6, that's arithmetic. So you could have used 2 arithmetic formulas to get this as well. That would have been an option for you. Okay, if you have that one memorized, arithmetic. That I think is lesson 2. I think we're doing arithmetic then. All right, so let's look at B. First of all, there's really 2 things going on there. One is I've got alternating signs, negative, positive, negative, positive, negative, positive. This is an alternating sequence, which I like to deal with the alternating part separately, really, because that's how it's kind of convenient in calculus for us to do that. So that's kind of how my mind frame goes, is towards what would be easier for me in calculus. And so I'm just going to work on the alternating part first and try to figure that part out. Then I'll work on the numbers. Let's see if this needs to be a 1, 2, 3, 4, 5. Alright, so let's see if I put it in there, if this will work. So if I put a 1 in, yeah, I get negative, 2 positive. So this is the alternating part. Now I don't have to worry about that part anymore. That's the alternating part. Now I'm just going to worry about the numbers. 2, 4, 6, 8, 13. I'm going to worry about those. So let's see. If I put a 1 in, I get a 2. If I put a 2 in, I get a 4. A 3 in, I get an 8. 4, 16. Do we kind of see where that's going? What if I did 2 to the n? Let's see if that works. If I put a 1 in, do I get a 2? Yep. 2, 2, 2, I get a 4. 3, I get an 8. Yes, that works. Now, this would be my a sub n term. And this is how I would write it, just because I'm kind of a calculus brain. Do you have to write like this? No. You actually could combine these together, and that would be perfectly fine. If you wanted to condense these, see how they have the same exponent? You could also write this as negative 2 to the n. That's perfectly fine, a little bit quicker to write. Either one of those is fine. Okay? How are we on nth term? All right. Let's look at number 2. Number 2 is the first one where we're going to need a calculator. When we're doing convergence and divergence in this lesson, I want us to use a calculator. There are other ways to do convergence and divergence, but for this particular lesson, I want us to use a calculator. Okay? So let me clear this out. Let me go to my calculator. Okay. So what I'd like to do, we're gonna graph. We're gonna use the graphing feature. I think that'll be a little quicker. Let's go into our mode, and we're gonna investigate one of the modes that we really haven't done before in class, and that's this sequence mode. We're gonna go over here and just play with it for just a bit, just for graphing. So let's go down here. We've done the other ones, right? We've done polar, parametric. Might as well do all of them. So let's do sequence mode. And then let's look at our window. So this is telling me my n, right? Sequences have n's. That's an n. So it's telling me I'm starting at an n of 1. I'm going to an n of 10. I've actually looked at this problem already, and I know that that's not enough terms. 10 terms is not going to be enough to tell whether it converges or diverges. So I'm going to have more terms. Let's make our n max to be like 60. Let's get 60 terms. And then I just leave those start and stop things alone at 1, and then I come down here where the x max is, and I'll put that at 60. Okay, so now let's go to our y equals. Let's put our equation in. This little thing right here is where we put the equation. It just means they're calling the function u of n, because that's our variable that's going to pop up. And so our equation is, 64 over 2n. Let's see if it will behave this time. Oh, it did behave this time. So we'll do 64 over 2n. All right, so let's look at the graph. So what's happening is you see each of these little points, those are terms. This is the first term, second term, third term, and so forth. And it looks like the values of the terms are approaching a particular number. Can you see that? They're approaching a particular number. And if we're not sure with 60 terms and we want to do more, we certainly can. And you can do as many terms as you want on there. But it looks to me like the values of each term is approaching 0. Do we see that? So that means that this sequence converges. It converges to 0. All right, so that's what I would write on my paper. So let's go to our paper. And so, again, there's other ways to do convergence and divergence, but for this lesson, I just want us to look at the graphs, okay? So this would be convergent. It converges, and it converges to 0. Now there was some confusion about convergence and divergence, so let's talk about it just a little bit more. What does it mean to converge to 0? Does that mean that I don't have an infinite series? That doesn't mean that, right? I still have an infinite number of terms. What it means is the term numbers keep getting larger, like the 100th term, the 1000th term, the millionth term. Those numbers, those values are just going to get smaller and smaller and smaller and approach 0, like 0.00001 or something. That's all that means. I still do have an infinite series. Or infinite sequence, excuse me, because it's just the individual numbers. It's just that those values are getting smaller and smaller. Does that make sense? Do we understand what it means to converge? The value of the term number, the value of the term itself, the 5th term, 6th term, 7th term are getting smaller and smaller and approaching 0. I still have an infinite number of them. Okay? All right. So on number 3, let's see, they want us to find the first 3 terms of the recursive sequence. Well, yippee, I already have the first term, so basically I need to find 2, right? This is my first term. A sub 1 equals 1. So just to investigate these little term number things, I'm going to kind of go through that process and make sure we completely understand what those mean. So if I want a sub 2, I'm putting a 2 here for n. That means that I'm going to do 3 times a sub 2 minus 1 plus 2. Okay, so that's what the term numbers are doing, right? I'm putting a 2 in for n. 2 minus 1 is 1. So what this really means is to get the second term, I would do 3 times, and that would be a sub 1, the first term, plus 2, or 9. Okay? Are we okay with the little term numbers? We know how that works, right? All right, so I'm just going to go to the third term. So we would do 3 times the previous term, which is 9, plus 2. And what is that? 11 times 3, or 33. So my first 3 terms are 1, 9, and 33. Okay, and that's just a reminder of what a recursive sequence looks like. Okay. So on number 4, they ask us to find the first 4 partial sums and the nth partial sum. So I'm looking for the first 4 partial sums and the nth partial sum. So to do the first partial sum, that's just the first term of the sequence. It's just 1 over 1 minus 1 over 1 plus 1. Now we are going to do this in the calculator also, but we also need to be sure we understand how to do it by hand. Okay, so that gives me 1 minus a half, or 1/2. That's my first partial sum. My second partial sum, what I do is I take my first term, which was 1/2, and I add to that my second term, 1 over 2 minus 1 over 2 plus 1. And that's 1/2 plus 1/6. And that's 2/3. So this is my first partial sum and my second partial sum. Everybody okay so far? Okay. So my third partial sum is where I take my first term, which was 1/2, and my second term, which was 1/6, and I add to it my third term. All right, my third term is 1 over 3 minus 1 over 3 plus 1. And that's the first term plus the second term plus the third term is 1/12. And that gives me my third sum of 3/4. Are we getting the pattern? Now this is the expanded way to do it, right? I'm working through every single piece. Are there shortcuts to it? Sure. Sure. Like you could take the sum and add 1/12 to it. I mean, there's other things you could do. But I'm completely expanding it out so there's no confusion. So I take the first term, so a sub 1 is 1/2, plus a sub 2 is 1/6, plus a sub 3 is 1/12. And I'm going to add the fourth term to it, which is 1 over 4 minus 1 over 4 plus 1. So that's the first term plus the second term plus the third term. Oops. plus the fourth term, which is 1 over 20. And that gives me my fourth partial sum of 4/5. So they want me to find the nth partial sum. So that means they want me to get a formula for the sums. So what I would need to do is write them out. So just so I can look at them: 1/2, 2/3, 3/4, 4/5. Are we seeing a pattern develop there? So if I put a 1 in, I want to get 1/2. If I put a 2 in, I want to get that, 3 and 4. The numerator is pretty straightforward, right? The numerator, if I put a 1 in, I just a 1. So my S sub n, that's my nth partial sum. It's going to be n in the numerator, right? We okay with that? That's an n. And what about the denominator? Wouldn't I just do n plus 1? Okay. So now let's look at a couple of different calculator input things for this. Okay, is everybody okay with doing it by hand? All right, let's go to our calculators. I'll show you my preference. Come on. Now, we could stay in sequence mode, but I really have found that I like, I like to go back to function mode for working with this stuff rather than staying in sequence mode. So I'm going to go back. I like to use sequence mode for graphing, basically. So let's go back and let's go back to function mode. And what I'd like to do is go to y equal. See if my window's crazy. Yeah, my window's crazy. Let's go to y equal and let's put in that 1 over in the thing that we just did. But we're using x's now, so 1 over x minus one over x plus 1. Okay. So to get my terms, really, I can just go to my table. I really like doing that. Let's go to the table. So let's look. See, I have a half here. That was my first term, was a half, right? I have a sixth. That was my second term, was a sixth. I have 1/12. That was my third term, right? And I have 1/20. That was my fourth term. So here, see my terms? Now it's not adding them up for me, but it's telling me what they are. Do we see that? So if I wanted my second partial sum, I would just add these two together. If I wanted my third partial sum, I would just add these three together. Does everybody understand that? Fourth partial sum, just add those four together. That's all I would need to do. All right, I like that. I like using the table. I think that's really handy to give us our term numbers. Okay. So let's go to the next problem. Let's go to number 5. And we have one more thing to do on the calculator, which is summation notation, but we'll do that in just a second. Let's go back over here. We're going to do it by hand first. We really need to understand how to do it both ways. We need to understand what's happening before we let the calculator do the work for us. Okay? Just punching buttons on a calculator is not that outstanding. Knowing what you're doing is way more outstanding. So what does this tell me to do? This tells me to take a 3, start at the third term, and go to the fifth term and add them all up. That's what it's telling me to do. So that means I need to take 1/3 plus 1/4 plus 1/5. That's what this math command is telling me. So when I add all that up, I get 47 over 60. So that's my sum, and we'll do that one in the calculator in just a moment. The next one is just weird, right? I don't even have a variable in there. Just a 2. What does that mean? That means the first term is 2. What about the second term? It's 2. The third term is 2. I mean, it's just, I guess, a little boring, right? Every term is 2. So it wants me to take the first term through the sixth term and add them all together. So that means that I would do 2 plus 2 plus 2 plus 2 plus 2 plus 2. There'd be 6 of them, and that would give me 12. That's what that's telling me to do. Okay, and the last part, this summation down here, and then we'll go back to the calculator. This is telling me to write this in summation notation. Now I have a lot of options, a lot of things that I could do. I'm going to take the easiest option, the most apparent option. So I think we can see it a little bit better up here. I'll put it up here. So here's my summation. I know I need a summation. That's what it tells me. I need sigma notation. I know I need a radical. I'm putting a radical. I know I need those things. I need a variable. I pick whatever variable I want. Typical ones. Okay, so my favorite is n. I don't know, I just like n's. But you'll see I and k and j, lots of different letters. Pick whichever one you want. I'm going to start somewhere, right? We got to figure out where to start, and I'm going to go somewhere. So since this starts at a 3, I'm gonna say that that's n, and then I start at 3. That's the most straightforward way to do it. And then I want to sum all the way to 77. Do I have to write like that? No. What if I wanted this to be n plus 1 under here? Then what would I start at? A 2, and I would go to 76. Okay, so yeah, there's a lot of different ways you could write it. I just took the most straightforward. Okay? If you wanted to start at 1, you could do that. I mean, it just depends on how you want to write it. So let's go to the calculator one more time, and let's look where the summation is in the calculator. So we're doing this one, and we got 47/60ths. Let me erase and go to the calculator. All right. Let's go to a clear screen. So the summation is under math. It's down at the bottom, down here. See right here? It's 0. If you get this, then you have the new operating system. If you get like something different than that, maybe it says SUM or something, then you have the old operating system. And if you have an 84, there's a free upgrade from TI. There's a free upgrade from TI, and I encourage you to get it. If you need help getting it, let me know. I can help you get the free upgrade from TI to get it to look like this. So we want it, this X is fine. We start at 3. We're doing that one from 3 to 5 and that was, when it was 1 over the variable, which for us is X. And then we hit enter, and it does it all for us, and it gives us 47/60ths, which is, you know, what we got when we did it by hand. Okay, so that's where the summation is in your calculator. All right, questions on that? Okay.